Welcome to the foldscope portion of the workshop. Alan Tian and Eden Hatley have shared a lot of interesting data and insights into blue-green algae blooms. The foldscopes are one more tool to use in our understanding, along with data collected from the Lake Partners program and through studies such as we've seen from Eden and Alan. A number of people interested in this workshop are situated along the Rideau Canal system. So I thought I would share with you a profile of the Rideau Canal waterway. By looking at a bloom to see what species group can be readily identified, this can be one of the first steps to understanding if an algae bloom can potentially be a threat by producing toxins or foul water. It can also help define some trends that may help us predict the likelihood of a bloom occurring in any given year, such as exceptionally high temperatures or below average precipitation. As Alan pointed out, our waterways are complex, interactive systems, and as emphasized in the October 2019 Nature article on the global lake studies, each lake can respond differently to important influences such as temperature, precipitation, and nutrient loading from agricultural activity. Before I get started with sharing a lake sample on the foldscope, I would like to point out that there are many excellent YouTube tutorials available from foldscope.com. If you want to know more about how to prepare or insert slides, to finding out what people around the world have been looking at with their foldscopes, or if you just want to register your own scope, I highly recommend that you visit their website.
Here, this is the front side of the foldscope, the blue side. This is where you're going to put your eye to look at your sample. The yellow side is the bottom section. And here we have a magnetic coupler. So you give it a tug, and this is where you're going to insert your sample. So the covered glass slip is the top side of your slide. You flip it over because you're putting it on the bottom side of your foldscope, and you insert it into the tabbed area one side, and then pull up the tab and insert it into the other side. On the other side, you place your thumbs on the perforated paper, and that enables you to move the stage essentially, left and right, and up and down. Then you take your LED magnifier, which is a light source, turn on your light, put it on the bottom. The magnetic coupler will make it attach easily to the bottom. And then you can look through the eyepiece and use this focus bar to focus on your mesh. Coupler on my phone so that when I place it over, it lines up, and as you can see, my phone now has an image of the micrometer mesh for the purposes of measurements. Just to give you an idea of how to focus, something to focus on, and also to give you an idea of sizes when looking through your foldscope. Over to the back of your foldscope, take the slide out from one side and then the other. Put that to one side, and now we're going to take a sample of pond scum I'm hoping that we'll get some spirogyra, sorry, not oscillatoria. I know we will get spirogyra because it's the dominant species group. It's very long filaments, very characteristic bright green. And this is where either a piece of tape or you first can use the cover slips that are really sticky tape. When you run out, you can always go to your regular cellophane tape to use as a cover slip. Turn it over, cover slip down, because you're putting it on the bottom side of your foldscope. The yellow side is the bottom side. And then insert your slide, one side, then the other. So I have my sample on the foldscope. And as you can see, hopefully, that we have spirogyra here, and the number of filaments that are really not in very good condition there. Perhaps there's a little critter in there. That's probably a rotifer. But once I have my algae sample on the screen, I can hit the button and take a picture. So that's essentially how we can share our samples. All you need is a couple drops of water, put it onto a cover slip with either tape or your cover slips that come in your package. Take a photo and then share it through email. Before we get started with a bit of taxonomy, at the outset, I would like to say I am far from an expert on phytoplankton. I would like to thank Dr. Kate Laird from Paleolimnology at Queen's for loaning me some very helpful books on common freshwater algae found in North America. I will not get into too much taxonomic detail of the diverse algae groups. There's an entire microscopic world out there. Fortunately, most of the cyanobacteria that I have encountered fall under two categories: unbranched filamentous genera, such as Anabina and Aphanizomenon on the left, and colonial non-flagellated genera, such as Microcystis and Warrenishinia on the right. As we have seen in Melbourne Bay Dog Lake, the dominant species of blue-green algae were Anabina species. Aphanizomenon is also present in Dog Lake on a regular basis, and they are both in the same category in this particular taxonomic key by Gary Dillard. How to identify 4 of the BGAs that are filamentous in nature? Anabina is a species made up of beaded filaments. There are 3 to 4 species in Melbourne Bay. This is one of the common species, probably Anabina spiroides, because its shape is a rigid spiral shape. Some of the filaments are straight, a rigid straight shape of filament, and others are curved rather loosely, as you can see in this photograph. So there are at least 3 or 4 species of Anabina. Aphanizomenon looks like clumps of cut grass.
That's because they are made up of very narrow filaments that are grouped together in fascicles. They are very easy to recognize. Not so easy if you're just looking at the individual filaments, which do come apart. Nostoc looks like garden peas. They are actually even about the same size. And they're also an olive green color. So if you cut one of these water peas open, they look like small versions of Anabina. Gliotrichia, here on the right, the large model, is a cluster of filaments that come together at one central point, and so they look like pom-poms floating in the water. I've added in this tiny crustacean called Bosmina, which is only about 400 micrometers in length, to give the perspective of how large these Gliotrichia pom-poms would be. They would be about 800 micrometers across. On the left, I have a photo of my mesh micrometer made from the Nelson Lab mesh. The field of view is approximately 1,000 micrometers across, which is equal to 1 millimeter. If I put my eye up to the lens of the foldscope, I can only see approximately 300 to 400 micrometers across. Also, when I take a picture of my sample, if I zoom in, and if I come back to my photo later and want to know how big a colony it was, it will be difficult to determine. If the size may be of importance, make a note on your phone picture that you zoomed in on. Take a mesh micrometer photo with the same amount of zoom. That will make it easier to determine size. Now, how can we identify Microcystis aeruginosa? Microcystis aeruginosa is a colony of cells that are approximately 5 micrometers in size, quite tiny. These cells are embedded in a mucilage. This mucilage is rather transparent or translucent, but the cells are a purplish black in color. Often the colony will be perforated, and even though it's flat, it might be curled over into different shapes. To me, the colonies of Microcystis aeruginosa look quite wispy. And also their dark color makes them very distinctive and easy to identify. In contrast, Microcystis floss aquae looks like porridge. The cells of the colony are so tightly packed that it looks like a flat blob. The blob is usually round in shape, although sometimes it can be elongated. So that is also very distinctive. It does not have really dark cells like in Microcystis aeruginosa. As for Warrenitia, this species is not flat, it is quite globular. It can consist of a number of spherical globs. And what makes it easy to recognize is the dark margins on the edges of the globs. Also, when you look at it under a microscope, along the edges you can see a translucent, transparent margin that is a sheath around the cells and sticking out of the sphere. On the day of collection, or if you just want to preserve your phytoplankton for a later date, you can put a few milliliters of water in a small jar and add rubbing alcohol plus several drops of iodine from your medicine cabinet. Voila, this is just like Lugol's solution from the lab. The iodine stains the starches in plant and animal cells. It does get damaged by sunlight, so you need to keep it in newspaper or a box. Here are some of the species groups that you may find in your water samples. Green algae, such as Spirogyra, are very common in eutrophic waters. As the name suggests, they have spiral chloroplasts. Desmids are a subgroup of green algae that are very distinctive and have beautiful shapes. Anchistrodesmus on the left here is shaped like a crescent moon, and this lovely species of Pediastrum is quite common in water samples. In the middle we have Denebrion, a very common species of chrysophyte in Dog Lake. My photo is not good, but they are a branching algae within a silica covering. They have the ability to photosynthesize or consume bacteria. Dinoflagellates, such as this one here, which is called Ceratium, are very common in Dog Lake. They do not produce toxins. Diatoms, which are represented in Dog Lake as well. Not Cyclotella, but they are a good example of how the cells are constructed. They are like a petri dish. Two halves are their silica test or shell, and inside are their organelles and their chloroplasts. And when in the case of Fragillaria, which is a common species in June in Milburn Bay, you have many diatom cells in a stack, and they adhere to one another. So you get these chains of diatoms that are varying numbers of cells. Tabellaria is also mentioned by the MECP phytoplankton specialists as being common at certain times of year in Dog Lake. Here is the bloom severity forecast for Lake Erie for 2020. This comes out from the National Oceanic and Atmospheric Administration, NOAA. They are predicting a low severity bloom this year. Based on observations from 2016 and 2018, when Cranberry Lake and Dog Lake had low precipitation and high BGA blooms, I'm going out on a limb to say that a low BGA severity year for Lake Erie may mean this year will be a bad BGA year in Cranberry Lake and Dog Lake. Let's hope I'm wrong. Well, whether we have a bad year or a good one, I'm hoping that you can share your observations with me from the following dates: August 16th, August 30th, and September 13th, plus or minus a few days. And I want to thank you once again for your interest, and I hope to hear from you through email.